This world is not what you think it is. This world is not what you think it is.
The derivation and definition of a linear aircraft model. In the introduction, they flat out say right here, this report documents the derivation, which means the origin, and the definition of linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. Everybody see that? Derivation means the origin. Definition means this is how it's defined. This is how it works. So they're talking about the equations, and you want to talk about the calculus and trig this thing gets into. The equations are based on these airplanes flying over a non-rotating flat Earth. Question: why would this be in any technical manual of anybody if it doesn't exist? I mean, think about it. They claim the Coriolis effect, that snipers have to calculate the spinning of the Earth, the Coriolis effect, when they're shooting at, a 1,000-yard shot or something. Yet they don't have to for Mach 1, 2, 3, 4 aircraft. You don't have to calculate the spin. No. This is just about, these planes fly over non-rotating flat Earth. So, well, Pastor Dean, this is what I heard. Oh, well, they're just doing that to simplify the equations. Oh, really? I'm sorry. I didn't know that NASA rocket scientists and MIT mathematicians couldn't factor in 8 inches per mile squared. I'm sorry, they have to simplify the math. Maybe they missed a class at MIT or something. I don't know. But this is crazy. Now you can try to dismiss this if you want to, but it's also in the conclusion, the concluding remarks of the report and all the math and the equations. Look at that. This report derives and defines a set linearized system matrices for rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. Let's keep going here. There's your definition of derivation: obtaining or developing something from a source of origin. Why would you develop the equations for aircraft to fly over something that doesn't exist? Oh, let's factor in the unicorn equation, just in case, the Pegasus, the flying horse equation. So, yeah. No, they're telling you it exists. Definition, of course, is a statement of the exact meaning of something. Think about that. The Central Intelligence Agency. Declassified document that we stole from the Russians from 1948. What's that? Yes, you will. You notice that. Sanitized, yes. Why would you sanitize scientific information about, look at this, this is what this one's about, scientific Earth measurements. Why would you redact anything concerning the true scientific facts of the Earth? I wanted you to see that scientific measurements of the Earth, June 1948. It was originally in the Russian language. This is the translated thing. Date distributed, July 1949, number of pages 19. Just so you can see, here's getting into it here. Now, notice it says, the paper says, outer gravitational field and shape of the physical surface of the Earth. Gives this guy's name, some Russian guy, Center Science Research, Institute for Geodetics, Aerial Surveying and Cartography, Moscow. Everybody see that? All right. You can go through this entire document if you want to. I'm just pulling out something that I found very interesting in 1948 from Russian scientists that was classified. They stated here that where it is not determinable at all of the points of space without the knowledge of the shape of the Earth, but since the shape of the Earth is not known. I'm not going to read all this, because if I read all this today, we'd be here for a long time. In fact, I cut out stuff. I just wanted you to see that a Russian scientific paper that was classified in 1948 states the shape of the earth is not known. Now let me remind you that we are always told, oh, we've known the shape of the earth since 300 BC. How did Russian scientists, and let me just say that Russian scientists are not stupid people. In fact, reading through their documents, they seem to be more honest with themselves than a lot of American scientists. All right, so Russian documents, CIA documents, declassified. Let's look at it. We're going to go down through some now here. I'm going to try to go pretty fast. This is the Army Research Laboratory. Notice every time when you see .mil, whenever you see .mil, in the United States, the only people that can have .mil, military. This is the Army Research Laboratory. Beacon position and altitude navigation aided by magnetometer. I'm not going to try to pronounce those people's names. You can see the document prepared by the University of Delaware, Department of Electrical and Computer Engineering, under contract to the U.S. government. I guess these people are dummies, right? They're stupid. All right? This tells you who they are. I'm not going to get into all that, but this tells you the PhDs and the people who were assisting this study. And here we find something. Problem formulation, coordinate systems. The motion of an object usually described by rigid body equations of motion derived from Newton's laws. This section summarizes and notates three kinds of coordinate systems. The first is the Earth-fixed coordinate system, which is fixed to the Earth with a flat Earth assumption. Okay, now remember, we're talking about beacons for aircraft, and aircraft flying, moving, and we're talking about stuff that's moving. Why would you assume, first of all, why would you use the term Earth-fixed? I'll deal with that in a second. And a flat Earth assumption. An assumption means something that is just known to be true. It's just assumed because it is known. Here we go. This is a different one. Everybody see where this came from? NASA.gov. You could interchange CIA.gov, NASA.gov, it's all the same. Okay? They work together. In fact, I believe that all high-level NASA people are spooks, is what I believe. All right? Here we have the singular arc time optimal climb trajectory of aircraft in a two-dimensional wind field. Oh, Lord. These guys. All right? NASA research, smart people are rocket scientists. Everybody said, I'm not a rocket scientist. Well, these are. All right? So this document goes on to say, in our minimum time to climb problem, the aircraft is modeled as a point mass, and the flight trajectory is strictly confined in a vertical plane on a non-rotating flat Earth. Do you see that? Does everybody see that? And then they've got this nice little equation here. Thus, the pertinent equations of motion for the problem are defined in its the state variable form as, and then they give you the math. Wait a minute, is this unicorn math? Is this Thor hammer math? Wait a minute, no, it's flat. Whoa, what flat? Non-rotating flat Earth math. Oh, I'm sorry. Could we just substitute Pegasus, unicorns? No, exactly. Let's keep going. Here, let's back up a little time. Everybody see this? NASA technical memorandum. Where'd it come from? NASA.gov, right? Declassified. Freedom of Information Act tells you all about it. Determination of angles of attack and side slip from radar data and the roll stabilized platform. Langley researched that. What's in Langley? Virginia? Yeah, CIA headquarters, exactly. Also, the National Aeronautics and Space Administration, Washington, D.C. Wait a minute, I thought they were in Florida and Houston, Texas. Oh, that's right. I'm sure they have an office. All right, let's keep going here. Here's the abstract. NASA Langley Research Center, technical memorandum, blah, blah, blah. Here is in the abstract. Basically what they're describing this manual is all about. It's a summary of it. Here's what they say. Equations for angles of attack and side slip relative to both rolling and non-rolling body axis system are derived for a flight vehicle for which radar and gyroscope attitude data are available. The method is limited, however, to application where a flat non-rotating Earth may be assumed. The application for this whole thing has to be based on a flat, non-rotating Earth.
We interrupt your regular programming to bring you reports of what is being described as an event of biblical proportions. Hospitals are inundated with dazed and confused members of the public suffering injuries and psychological trauma after what is believed to be a sudden tilt of the Earth, estimated to be about 23.4 degrees. The scientific community is said to be baffled by the unprecedented shift, which challenges the long-held belief that the Earth was a spinning globe. We used to think the Earth was covered in bendy water held down by mathematical formula and thought experiments, said a prominent pseudoscientist who wished to remain anonymous. Members of the Flat Earth community have been drafted in to help Australians cope with the psychological trauma of suddenly finding themselves the right way up. NASA frontman Neil Degrasse Tyson was unavailable for comment, claiming to have lost his microphone. Britain's Big Bang poster child, Professor Brian Cox, has reportedly barricaded himself inside Europe's CERN facilities to escape angry hordes of heartbroken nerds. Prominent members of the academic community are said to be redefining the word level, and politicians have been warned to refrain from using the word global to fit with the new paradigm shift in human consciousness and waking up to the realization that we never did live on a spinning ball. Stay tuned for more reports on the Flat Earth Awakening as they come in.
Wait a minute, how many documents are we into here? I'm going to read that again. Equations for angles of attack, side slip relative to both rolling and non-rolling body axis system are derived for a flight vehicle. So we're talking about stuff that flies. And for which radar and gyroscope attitude data are available. The method is limited, however, to application where a flat, non-rotating Earth may be seen. To say that the method is limited to a flat, non-rotating Earth means it does not work for a spherical Earth. This is interesting because he talks about, it gives you this little frame reference. Look at north, south, east, west, right? And they're telling you that, again, that represents the Earth fixed axis system. Everybody see that, right there? The radar provides range, azimuth, and elevation data from radar site to the vehicle throughout flight. So we're talking about stuff happening throughout flight, right? The data in conjunction with wind data can be easily converted to pitch, blah, 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 flight path angles. It is assumed herein that the Earth is represented as a flat and non-rotating reference frame. Well, why do I say Earth fixed? Isn't it supposed to be spinning, tilted, orbiting, flying through the universe? Yet the stars never change in the sky, right? The night sky. But yet we're spinning, flying, orbiting. Millions of miles. Been doing it for thousands of years. Nothing in the night sky ever changes. They know. Come on, they know. It is assumed herein that the Earth is represented as a flat, non-rotating reference frame. Yet they're going to tell us snipers have to adjust for shooting a 1,000-yard shot. That takes about 2 seconds, maybe less than that. But you don't have to calculate the Earth's spin for an aircraft, for a helicopter, a drone. The space shuttle, I'll show you that in a minute too. Let's keep going. Here it is. Notice it says, also by definition, the X and Z plane will be vertical, perpendicular to the horizontal plane of the Earth at all times. The horizontal plane of the Earth at all times. Now, here's a doctoral dissertation by a PhD candidate that became part of this European Control Conference. In fact, I guess he graduated, but this doctoral dissertation that he began to speak to, I guess, the European Space Agency or whatever, a new path planner based on flatness approach, application to an atmosphere reentry mission. This was designed for the space shuttle, quote, reentry. And it's funny, they put orbit and reentry and stuff like that into quotations. And I'll explain all that next week. We'll get into that next week. But Notice the outline of his doctoral dissertation, statement of guidance problem. Why would you have a guidance problem? Well, if you're basing stuff on a spherical Earth and it's really flat, then you're going to have a guidance problem. Right? So this guy comes along and goes, you know what? We got to get back to a flatness approach. I'm not making this up. Right? Flatness-based trajectory planning. Here we go. He's talking about for this little vehicle right here. And we'll keep going. Notice he says model in flat Earth coordinates. Everybody see that? Again, this doesn't exist, right? Flat Earth doesn't exist, but we're going to have a model for it and all this unicorn math. Sprinkled with fairy dust. So this guy's doing a doctoral dissertation in this present time to help with guidance system of the shuttle, and now we have unmanned shuttle system. But he's doing this and saying we've had guidance problems, so we got to go to a flatness approach, to a flat Earth model. Now I'm going to tell you, this guy's way smarter than me. I couldn't do this kind of math, not even in my dreams. Okay? But he does. And he says, guys, we need a flat Earth model. And here's the math for it. Shall we keep going? Notice this. Assumptions, meaning things we assume are true. Flat Earth. Coriolis and centrifugal forces neglected. Here's a doctoral candidate who graduated, got his PhD, becomes a speaker to the European Control Council, and he's telling them it's a flat Earth. We ignore Coriolis, meaning the spin of the Earth. It's completely ignored. Here's MIT, Massachusetts Institute of Technology, the top technical school in the country. Or at least one of the top. I'm sure they argue among themselves who's the top. What's this? dspace.mit.edu. Right? Property-based system design method with application to targeting system for small unmanned vehicles. So this is a targeting system developed Massachusetts Institute of Technology, blah, blah, blah. Tells you who it is, the author of this. And then in the description it says 3 targeting methods were considered assuming a flat Earth. Whoa, 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 whoa. Why would an MIT professor, PhD, why would he assume the Earth is flat? The evaluation revealed a descending utility order, flat Earth, and range based upon the system's requirements. I mean, these and aeronautics and astronautics. Flat Earth assumption, mind-blowing. All right, let's get back to our documents, government documents here. Just wanted you to see MIT and other doctoral candidates and PhDs saying it's flat and it's not moving. Calculation of wind compensation for launching unguided rockets. So we're talking about rockets by Robert L. James Jr. and Ronald J. Harris, Langley Research Center, Langley, Virginia, Langley Field. I would say pretty important stuff, right? Right. But who reads this stuff? Who stays up all night and all day reading stuff? I do. All right, technical note. Here we go. Summary, method for calculating wind compensation for unguided missiles. It is derived from which has a greater degree of flexibility than previously proposed methods, blah, 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 blah. And they get into it. So they're telling you, summary, here's what we're up to, trying to figure out how to guide rockets. Yes, sir. Linear aerodynamics, yes. Coefficients with respect to flow, incidence angles are used, launch angles for wind compensation. I mean, it's pretty serious stuff, right? I think you'd probably need to get it right. I know if I was their general or their boss, I'd say you guys better get it right. This stuff's expensive, so let's get it right.
Better work.
Right, it better work. Let's look at this. It says trajectory simulation incorporating the above requirements is presented in reference 8. In addition, To the above requirements, this simulation assumes a vehicle with 6 degrees of freedom and aerodynamic symmetry and roll, and the missile position, again, space will deal with that. They don't even, it's not what they're talking about. What we think, what they've told us, and what they know space is, 2 different things. So when they say it, they don't mean what they've lied about. The missile position in space is computed relative to a flat, non-rotating Earth. April 1961, NASA technical document for calculating unguided missiles, not anything we're sending into space. Just unguided missiles, like the V-2 was an unguided missile. Let's keep going here. Here's another one. Okay, completely different document. Where did it come from? NASA.gov, right? Unpublished preliminary data, atmospheric oscillations, tells you the people. Georgia Tech project. Georgia Tech, here we go, right? My wife's brother is a professor at Georgia Tech. He would be losing his mind if he heard this, but his own university has been part of this. Under contract, Georgia Tech project, contract, prepared National Aeronautics and Space Administration. So this was in conjunction with their engineers. Engineering Experiment Station, Georgia Institute of Technology, Atlanta, Georgia. Blah, blah, the requirements for additional copies. Talks about that, says the Department of Defense contractors must be established for DDC services or have their need to know certified by the cognizant military agency. So this was not to be passed around. This was need to know. All right. Georgia Tech project, just so you see it. Boom, boom, April 1965. Tells you the abstract, develop present theories of atmospheric oscillations, blah, blah, blah. I don't have to. All right. A model frequently used is that of, everybody say it, flat and rotating Earth. The most one can profitably simplify the problem is to consider the isothermal atmosphere, plane level surfaces, and a non-rotating Earth. NASA.gov. Now this is general equations of motion for a damaged asymmetric aircraft. So what they're trying to do is fix equations if a plane loses part of its wing or tail fin or whatever, how to compensate and all that stuff, right? So that's what this is about. And the technical manual gives you this stuff. The introduction, here's the introduction, right? Just so you know, it says, in order to analyze the dynamics of damaged aircraft, the dynamic equations of motion must properly reflect the underlying physics. Now, I want to say that again. I want everybody to pay close attention. They're telling you right here in the introduction of this, and they're showing you a damaged aircraft. They're saying, in order to analyze the dynamics of damaged aircraft and dynamic equations of motion must properly reflect the underlying physics. It must, what we're going to do here must reflect the true physics. Physics. People say, you don't understand physics. Okay, well, these people do. All right. Who are we talking about here? The American Institute of Aeronautics and Astronautics. And here's what they say: rigid body equations of motion, reference to an arbitrary fixed point on the body. There are several approaches that can be used to develop the general equations of motion. The one selected here starts with Newton's laws applied to the collection of particles defining the rigid body. Any number of dynamics or physics books can serve as references. So they're saying the physics books can serve as references. So in this paper, the rigid body equations of motion over a flat, non-rotating Earth are developed. Why? Why? So you're telling me that the physics of a non-rotating flat Earth are the proper physics in a NASA document. Here we go. You can tell when they're older documents. Atmospheric refraction errors for optical instrumentation. Fun reading, folks. I'm telling you, fun reading. There you have it. Tells you technical memorandum, blah, 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 same thing, preliminary report. October, what do we got? See, we're back it up, 1953. White Sands Proving Ground, La Cruces, New Mexico. Where's Area 51? It's in New Mexico, I know, but I don't know where. So, anyway, here we go. Look at this here. Just wanted you to see the signatures, real signatures. Dr. Fred Hansen, Dr. J.W. Molnar, or whatever. James C. McNatt, Lieutenant Colonel, United States Air Force. Thomas W. Morgan, Major, United States Air Force. Systems and Engineering Branch, Flight Determination Laboratory, White Sands Proving Ground. All here, right? Dr. So-and-so, Dr. So-and-so, General so-and-so. I guess they're stupid. This document was not to be seen. This document contains information affecting the national defense of the United States within the meaning of the espionage laws, Title 18 U.S.C., Sections 793 and 794. Its transmission or the revelation of its contents in any manner to an unauthorized person is prohibited by law. So this was classified in the 1950s. It's talking about basic equations for atmospheric refraction and all this stuff. It says, here, now I want to point this out. Present equations hold for any altitude. Everybody see that? I don't have time to read all of it. Present equations hold for any altitude. All right, let's see what they're talking about. Table of contents, introduction, validity of flat Earth assumption for atmospheric calculations. Validity. You know what validity means? Something that is a solid fact. Let me back up. Remember, present equations hold for any altitude. So some of this study of basic atmospheric equations, this is for any altitude. And this is the introduction. This is the table of contents. Introduction, the validity of flat Earth assumption for atmospheric calculations. If it wasn't flat, if the Earth was not flat, why would you start off a classified, under threat of law in the Espionage Act, why would you classify that? It's all here, folks. Introduction here says a comprehensive study of atmospheric refraction errors for optical instrumentation. What is it based on? Based on a flat Earth assumption, will be published subsequently. The relative mass of the atmosphere at any elevation angle is given approximately by the cosine of the elevation angle. I may be pronouncing some of this wrong, but listen, this relationship is correct for a flat Earth and a flat atmosphere. This relationship is correct for a flat Earth and a flat atmosphere. And they're going to publish these results. So we just saw one document say, this is the correct underlying physics, flat non-rotating Earth. We see this document right here say, this is correct for any altitude. Validity of flat Earth assumption. Validity. They're not saying, okay, see what some of them, this is what some of them say, that the flat Earth assumption is just to simplify things. But what this is saying is this so-called flat Earth assumption is valid. It's valid. Do you see it? Zoom in on it a little bit just so you see it. Validity of flat Earth assumption. Just so you know, the definition of validity. The quality of being logically or factually sound. Let's keep going here. Assumption. And anyway, let's just say that they didn't put in the validity. They just used the word flat Earth assumption. You hear that a lot. Well, the assumption, a thing that is accepted as true or is certain to happen without proof. I mean, we don't even need proof of this anymore. This is what is assumed to be true by the scientific community, by the governments of the world. What's this one? This is NASA Technical Memorandum, nasa.gov, mathematical model of a CH-53 helicopter. You guys know a helicopter pilot, right? So here's the NASA manual on that. Ames Research Center, Moffett Field, California. Equations of motion. The helicopter equations of motion are given in body axes with respect to a flat, non-rotating Earth. Meaning the helicopter takes off, it doesn't have to worry about the Earth spinning below it. Here's another one, vision-based mobile target geolocalization and target discrimination using Bayes detection theory. Oh, it's a mouthful, right? This is a more modern, I can't remember the year on this one, but anyway, you see this is the Academy Center for the United States Air Force, U.S. Air Force Academy, UAS research, and this is for targeting for unmanned vehicle, aerial vehicles targeting manual. It says the objective of geolocalization problem is to estimate range to target, which can be estimated using the flat Earth model shown in figure 2, which would be this little thing right here. No curve. Do you notice? The flat Earth model. And your little aerial craft locating a target. Now, if this line was curved here, as it does, 8 inches per mile square, that line is going to intersect at a different point. I'm not a geometry teacher, but that I know. Maybe it's just from golf, right? Flat Earth model. Range estimation using flat Earth assumption. Unmanned vehicle targeting manual from ResearchGate, but of course we showed you, United States Air Force Academy. Does everybody see that? Look at this. A key element in determining point-to-point acoustic transmission is modeling the variation of effective speed and sound through the lower atmosphere. Oh, did I forget this? Oh, yeah. Army Research Laboratory. This is another one. Calculating low atmosphere profiles, sound speed at night. So calculating sound speed, all right? Pretty important stuff. It says to briefly examine short-range acoustic attenuation at night, we use low atmosphere profiles of wind speed, temperature, relative humidity shown before as input to a flat Earth non-turbulent acoustic propagation model called the Windows version scanning fast field program. Propagation of electromagnetic fields over flat Earth. Army Manual, February 2001. You can say, oh, Pastor D, the 1950s stuff and the 1960s stuff, oh, they just didn't know. They've learned stuff since, right? Nope. They tell you right here. And you go into the manual, here's the table of contents. It says comparison of principal fields from an ideal dipole oriented perpendicular to a horizontal and homogeneous flat Earth. Army Manual. They tell you right here, it's assumed that the transmitting antenna and target or receiver are located above but near the surface of a flat idealized Earth. Over and over again. I mean, I could do this. Guys, I could do, look, here's another. I even forgot. I thought we were at the end. Here's another one. Closed form solution for ballistic vehicle motion. Ballistic vehicle motion. A closed form solution is developed for the motion of a ballistic vehicle entering the atmosphere over a flat, non-rotating Earth. Frank J. Barbera, Cayman Sciences Corporation, Colorado Springs, Colorado. Closed form solution for ballistic vehicle motion. Meaning we got to know where this thing's going to come down. Payloads for spinning projectile. Army. Think you need to know where artillery is going to land? Look here. Projectile flight dynamics. A 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. The assumption of these equations assume a flat Earth. These equations. A whole bunch of math we're going to do. BG Karpov experimental observations of dynamic behavior of liquid-filled shells. U.S. Army Ballistics Research Laboratory, Aberdeen Proving Ground, Maryland, August 1961 is a reference to this. But he says, and again, a projectile. You want to know where that artillery round is going to land. And what this study is, the one that has a solid explosive versus one that has a liquid payload. They're talking about chemical weapons or biological weapons. So they want to know, figure out the equations. So a 6-DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. These equations assume a flat Earth. Again, why would you do unicorn math? Why would you do Thor hammer math if they don't exist? Why would you try to calculate ballistic missiles, unguided rockets, shuttle landings? Why would you base all your equations, all of your science on a flat Earth, non-rotating, non-moving, stationary atmosphere if it doesn't exist no more than a unicorn or Thor's hammer?